Today we're going to be talking about dividing polynomials. In our first example, we have a monomial on the bottom and we have a polynomial on the top. And there's two different ways that you can go about simplifying this or dividing this. Option A, you can factor out the common factors from the top. So we have a 5 in each term. You go with the lowest exponent on A, so I have an A and we have a B. So I'm left with A minus 3b squared plus 2a squared b to the third all over 5ab. Now because you're multiplying on the top and this 5ab is on the bottom, you can cancel those out and you're just left with a minus 3b squared plus 2a squared b to the third. Now this works if there's a monomial on the bottom. This other option B also works only if there's a monomial on the bottom. So there's nothing being added or subtracted on the bottom, so you can separate this out into individual fractions. By that I mean you can put the first term on the top over your denominator. You can put the second term on the top over your denominator. And then you can put the third term on the top over your denominator. So then from here, just cancel. The 5's cancel. The b's cancel. A cancels, and that becomes just an A. So I'm left with just an A for that first term. Minus 5 and 15 cancel to be a 3. A and A cancel. B squared and B cancel so that I have a B on top. So that should be a 3. Now I noticed I canceled, that should be a B to the third, so this should actually be B squared. I was cheating and looking over at this example because I knew these should work out to be the same thing. Plus, that changes to be a 2A squared and B to the third. And again, these two things worked out to be the same thing. Okay, long division, using long division to divide. And you don't need to write this down, but don't just fast forward through it, because this is important that you know how to do long division with numbers so that we can then do it with polynomials, because that's what our goal in today's lesson is. So you have to look, 23 goes into 145. So 23 goes into 145 6 times. 6 times 23 is 138. Then you subtract. And you get 70. I bring down my 3. 23 goes into 73 3 times. 3 times 23 is 69. I then subtract and get 4, and I bring down my 8. 23 goes into 48. 2 times 23 is 46. I subtract and get 2. I bring down my 7. 23 goes into 27 one time. 23 minus 27 is 4. So my remainder is 4. So how you would write that as a mixed number, your remainder, which is 4, over 23. So your remainder over what you divided into. Now we're going to divide polynomials using long division. So the x minus 5 goes on the outside, And in the inside, we have x squared minus 2x minus 15. Now notice how I have x squared, so x to the second power, x to the first, and then technically x to the 0 power. If you didn't have this 2x in there, you'd have to put 0x. Okay, so now, two ways you could think about it. One of them, take x squared divided by x. X squared divided by x. That simplifies to be x. So that goes above my x term. Now you take this x and you multiply it to both the x to get an x squared and to the negative 5. Now remember, you're subtracting here. What I often like to do is I like to often change the signs and add. Okay, so when I subtract, I get 0 there. When I do 2x minus a negative 5x, well, that's going to be a positive 3x. Now bring down the negative 15. Now take this 3x and divide it by x. 3x divided by x to get 3. Another way you could think about it is x times what gets me 3x. But I started using this method a few years ago and I find the students tend to like it. So 3 is your result, so the plus 3 goes up top. Now plus 3 times x, that's 3x. 3x times by a negative 5 is a negative 15. Okay, remember you're subtracting. You can use my trick when you change all the signs and then add, but or you could think about it as 3x minus 3x is 0. Negative 15 minus a negative 15 is a 0, so we have no remainder. So your answer is x plus 3. Next example, simplify. Make sure you guys realize one thing. What this means is a squared minus 5a plus 3 divided by, because remember negative exponents take and put a polynomial in the bottom. Now what I would do if I was you guys, we have a negative a plus 2. Put your variable first. And don't get frightened by the negative a. It's not going to be that bad. A squared minus 5a plus 3. Okay, so what times negative a gets me a positive a squared? Or you could think about it like a squared divided by a negative a, that simplifies to be a negative a. So that's how I know what goes up top. Then you take and you multiply this negative a to both of those two terms. A squared minus 2a. Now remember, you're subtracting. So a squared minus a squared, that goes to 0. 5a minus a negative 2a, that is a negative 3a. You might want to over on the side do a negative 5a minus a negative 2a. Okay, now bring down the 3. So now, what times negative 3a gets me negative a? Or what you could do is you could do negative 3a divided by negative a. That gets me a positive 3. So that's going to simplify to a negative 3a. 3 times 2 is 6. Remember, you're subtracting. A trick that I do, honestly, guys, when I subtract, because I got these wrong in high school all the time. So I had to come up with a trick that was going to help me. I changed all of these signs to the opposite sign and then just added, because then those go away, and then I have 3 minus 6, that's going to be a negative 3. Now I know that I'm done because the exponent on my variable here, which is technically 0, is 1 less than my exponent up here. So I know I'm done. Now your answer is going to be this, negative a plus 3 plus your remainder over negative a plus 2. Okay, synthetic division. There's actually an easy way to do long division by doing synthetic division. So write down these steps. You write the coefficients so that the degrees of the terms are in decreasing order. If you're missing a power, like if it goes from x to the third to x to the first plus 3, you're going to have to add in a 0 for your x squared term. Okay, so and then make sure you change it to x minus r in the box. Okay, multiply the first coefficient by r and write the product under the second coefficient. Add the product and then repeat until you get your final answer is the remainder. Now honestly, you guys are probably going, what is this talking about, Marnell? What are you doing? So if you remember this example from earlier, we're not going to use long division. We're going to use synthetic. And I think you guys are going to like synthetic a lot better. So what you do, you have a little box. This term right here, you take this number. Now make sure you always change it to x minus whatever. It's already in that form, so I could just take that number, 5. Now take the coefficients from that polynomial. Make sure if you're missing, like if this term wasn't here, you would have to add in a 0. But it is there, so I'm going to erase that. So take those coefficients. My coefficient on the x squared is 1. My next coefficient is negative 2. My next coefficient is 15. Okay. Now what it means is bring the first coefficient down. Slide that 1 right on down. Then you take the 1 times the 5. So 1 times 5 goes here. 1 times 5, oh, that's 5. Then you add them. And I always joke that I want a guy named Adam in my class. You add these two numbers together to get 3. Then you take and 3 times 5, this number here goes here, that's 15. Then you add them. This last number here is our remainder. We don't have any remainder, so what you have here is you have the coefficients of your new polynomial. Okay, my new polynomial, you decrease your coefficients by 1, so that's x plus 3. I started with an x squared. My new coefficient down here is x plus 3. Okay, our next example, using synthetic to define this. Okay, make sure this term that you're dividing, you change it to x minus a negative 2. So in my box, you put a negative 2. And then you put the coefficients of this polynomial. 1, 4, negative 6, negative 4. Okay, now bring down the first one, 1. 1 times negative 2, negative 2. You add these two numbers. 2 times by negative 2 is a negative 4. You add those numbers. Negative 10 times by negative 2 is a positive 20. You add those numbers to get 16. I always put a little dash. That's my remainder. So your answer, remember I started with an x cubed. This number down here is the coefficient with 1 less degree. So I'm x squared plus 2x minus 10 plus my remainder of 16 over what I divided in, which was x plus 2. Okay, this is our last example. Using synthetic division to divide these polynomials. So, using synthetic division to divide those, the coefficient on this has to be 1. So what I'm going to do is I'm going to write it like this. Okay, now the coefficient on this needs to be 1. So I'm going to multiply by 1/2 each term on the top and bottom. So I'm multiplying that polynomial by 1/2. I'm multiplying the bottom polynomial by 1/2. Because that's going to now change that. That's going to make my life easy. And I'm going to now be able to use synthetic division. When I multiply by 1/2 on the top, we get 2y cubed minus 3y squared, don't forget your squared, plus 2y minus 1/2. Okay, so in your box, you're already in y minus, so I just put the positive 1/2 in. Then I put a 2, a negative 3, a 2, and a negative 1/2. Bring down your first power. 2 times 1/2 is going to be 1. Now you add those to get a negative 2. Negative 2 times 1/2 is a negative 1. You add those to get a positive 1. 1 times 1/2 is a positive 1/2. You add those to get 0. So I have no remainder. That's actually kind of nice. I have no remainder there. So that means I started with a y cubed. Your answer is 1 degree less. So that's going to be a y squared minus a 2y plus a 1. Or a 2y squared minus a 2y plus 1. Okay, use synthetic division to divide. And please try and use synthetic division. It's something that's super new to you guys, but it actually makes our lives easier.